Elon Musk just broke his silence about 3I/ATLAS, and his warning about a potential collision trajectory is sending shockwaves through both the scientific community and social media worldwide. In a series of posts that quickly went viral, Musk, who has access to SpaceX's advanced tracking systems and direct communication with NASA, revealed something the space agency hasn't publicly acknowledged. ATLAS's trajectory has changed. According to Musk's calculations based on SpaceX tracking data, the mysterious interstellar object is no longer on a safe flyby path. It's now on a trajectory that brings it dangerously close to Earth's orbital path, with a potential collision window opening in approximately 28 days. Musk didn't mince words. The probability of impact is non-zero and increasing. NASA knows this. They're not telling you because they don't want panic. But people deserve to know what's coming. He followed up with SpaceX tracking data showing Atlas making systematic course corrections that have altered its path by millions of miles. Corrections that have progressively brought it closer to a direct intercept with Earth. But here's what makes Musk's warning particularly alarming. He's not just raising the alarm. He's announced that SpaceX is already developing emergency response options, including potential missions to alter ATLAS's trajectory or deploy defensive systems. When someone who literally builds spacecraft for a living starts talking about planetary defense in real time, it's time to pay attention. Before we break down Musk's trajectory analysis and why NASA won't confirm his warnings, hit that subscribe button and smash the like. Because what you're about to learn about Atlas's collision course will completely change how you see the next 4 weeks. Musk has been called alarmist before, but when he's warning about collision trajectories using his own tracking data backed by SpaceX engineers, we can't afford to dismiss it as hype. Let's examine exactly what Elon Musk revealed about ATLAS's trajectory, because the specifics are both detailed and deeply troubling. According to data Musk shared from SpaceX's tracking network, Atlas has made 23 distinct course corrections over the past 6 weeks. Each correction was small, velocity changes of a few hundred miles per hour, trajectory adjustments of a few degrees. But cumulatively, these corrections have moved ATLAS from a safe flyby path to one that intersects Earth's orbital zone. Musk posted detailed orbital mechanics calculations showing Atlas's original trajectory would have passed Earth at approximately 8 million miles distance, well beyond any collision risk. But the cumulative effect of those 23 maneuvers has reduced that closest approach distance to roughly 180,000 miles, less than the distance to the Moon. A SpaceX engineer who worked on the trajectory analysis explained the concern. When you see systematic course corrections that progressively reduce closest approach distance, that's not random navigation, that's targeting behavior. Atlas is steering itself toward Earth with deliberate calculated maneuvers. The question is whether it plans to pass by at 180,000 miles or if additional corrections will bring it even closer. But Musk's warning goes beyond just the closest approach distance. He identified a specific window, 28 days from his initial warning, where Atlas's projected position intersects with Earth's orbital path. If Atlas continues current trajectory trends and makes additional velocity adjustments, it could position itself directly in Earth's path with timing that suggests deliberate intercept. The SpaceX tracking data shows Atlas accelerating at specific intervals that maximize gravitational assists from planetary positions. This is sophisticated orbital mechanics, using planetary gravity to modify trajectory with minimal fuel expenditure. It's exactly what spacecraft mission planners do when designing efficient routes through the solar system. Musk emphasized the targeting precision. Atlas knows orbital mechanics better than we do. Every adjustment is perfectly timed and positioned to alter trajectory efficiently. This isn't a comet drifting on momentum. This is a spacecraft executing a complex navigation sequence, and that sequence is pointing it toward Earth. The businessman also revealed that SpaceX detected something NASA hasn't publicly mentioned. Atlas's velocity relative to Earth is decreasing. When objects pass by planets on hyperbolic trajectories, they accelerate as they approach and decelerate as they recede. but Atlas is showing velocity decreases that suggest active braking, as if preparing to match Earth's orbital speed rather than fly past at interstellar velocities. Musk's analysis included probability calculations that generated significant controversy. He assessed a 12% probability of actual impact with Earth based on current trajectory and observed maneuvering patterns. While 12% might seem low, in planetary defense terms, any probability above 1% is considered extremely serious. For comparison, the asteroid Apophis had a briefly calculated 2.7% impact probability in 2004, and that was enough to trigger international attention and emergency tracking protocols. Atlas, at 12%, represents a threat level roughly 4 times more serious, yet NASA hasn't activated visible emergency response procedures. Musk didn't just issue a warning, he announced that SpaceX is already developing response options. And the scope of what he's proposing reveals both the seriousness of the threat and the limitations of our defensive capabilities. SpaceX has apparently been designing mission profiles for rapid deployment spacecraft that could rendezvous with ATLAS and attempt to alter its trajectory. Musk released preliminary designs showing modified Starship spacecraft equipped with systems for either kinetic impact or close proximity nuclear detonation, the 2 primary methods for deflecting incoming objects. The kinetic impact approach involves slamming a spacecraft into ATLAS at high velocity to change its momentum. NASA successfully demonstrated this technique with the DART mission. But Atlas presents challenges that DART's target didn't. It's much larger, it's moving faster, and most critically, it's maneuvering. Hitting a stationary asteroid is hard. Hitting a spacecraft-sized object that can dodge is exponentially harder. A SpaceX mission planner involved in the concept work explained the difficulty. We're basically trying to design a mission to intercept and deflect something that has superior propulsion and maneuverability. It's like trying to ram a fighter jet with a slower aircraft. Even if we get close, ATLAS could simply accelerate or change course to avoid impact. The nuclear option, detonating a warhead near Atlas to vaporize surface material and create thrust that pushes it off course, is more promising but fraught with complications. First, it requires international approval to launch nuclear weapons into space, violating several existing treaties. Second, we don't know what ATLAS is made of or how it would respond to nuclear detonation nearby. Musk addressed these concerns bluntly. Treaties are written for normal circumstances. This isn't normal. If we face an object on collision course with Earth, we use whatever tools we have, regardless of treaties. Better to violate space weapons agreements than watch a city get obliterated because we were worried about paperwork. But the most revolutionary aspect of Musk's proposal involves using multiple Starship spacecraft to create a gravity tractor, positioning spacecraft near Atlas, and using their combined gravitational pull to gradually alter its trajectory over time. This is the gentlest deflection method, but requires weeks of time and assumes Atlas doesn't resist or counteract the gravitational influence. SpaceX has apparently conducted preliminary mission planning showing they could launch the first trajectory modification mission within 12 to 14 days if given approval. That's remarkably fast, leveraging Starship's rapid reusability and SpaceX's launch infrastructure. But 12 to 14 days leaves a narrow window given Musk's 28-day collision timeline. However, there's a darker interpretation of SpaceX's rapid response planning. Some analysts suggest Musk is using the Atlas situation to advance his Mars colonization agenda by emphasizing human vulnerability and the need for backup planetary colonies. Whether his warnings are purely about planetary defense or also strategic positioning for SpaceX's business interests remains debated. Musk's public warnings have created a firestorm of controversy with NASA, revealing deep tensions between commercial space companies and traditional government agencies about who controls information during potential crises. NASA's official response to Musk's trajectory warnings has been carefully worded and notably restrained. NASA continues to monitor Object 3I/ATLAS using multiple tracking assets. Current trajectory assessments do not indicate imminent collision risk with Earth. We urge caution about trajectory predictions from non-peer-reviewed sources. That statement is diplomatic language for, we think Musk is wrong, and creating unnecessary panic. But notice what NASA doesn't say. They don't provide their own trajectory data. They don't explain why SpaceX's calculations would be incorrect. They don't address the specific course corrections Musk identified. Their response is dismissive without being substantive. A former NASA administrator explained the agency's dilemma. NASA can't openly contradict Musk without revealing classified tracking data that might confirm some of his concerns. Reassurances and hope Musk backs down or public attention moves elsewhere. But Musk has not backed down. Instead, he's escalated, releasing more detailed tracking data and challenging NASA to publicly share their trajectory models. He's framed this as a transparency issue, claiming the public has a right to know about potential threats, regardless of whether that information causes concern. The tension reveals a fundamental question about crisis communication. Who decides what the public should know? NASA argues that premature warnings based on incomplete data cause more harm than good. Musk argues that keeping people in the dark until it's too late to respond is unethical and potentially catastrophic. Multiple space scientists have weighed in on the debate, and they're surprisingly divided. Some support NASA's caution, noting that Musk has a history of dramatic statements and that SpaceX's tracking data, while sophisticated, isn't as comprehensive as NASA's global network. One planetary scientist argued, Musk is looking at tracking data from SpaceX's limited observation windows and extrapolating trajectories that NASA's more complete data might not support. He's also not an astronomer or planetary defense expert. He's an engineer and businessman who's really good at rockets, but may be out of his depth on trajectory prediction for complex objects like ATLAS. Other scientists have defended Musk's right to share his analysis. They point out that SpaceX's tracking capabilities are genuinely advanced, that having multiple independent trajectory assessments improves overall analysis, and that the historical record shows government agencies often downplay risks to avoid panic until threats become undeniable. A space policy researcher described the broader implications. We're watching a historic shift in who controls information about space threats. For decades, government agencies had a monopoly on tracking and assessing these risks. Now private companies like SpaceX have equivalent or sometimes superior capabilities. The old model of centralized information control is breaking down, whether NASA likes it or not. To understand whether Musk's warnings are justified or alarmist, we need to examine what multiple tracking sources are actually observing about ATLAS's trajectory. Independent observatories worldwide have confirmed that ATLAS is making course corrections. The existence of these maneuvers isn't disputed. Even NASA's carefully worded statements acknowledge orbital variations. The debate is about what those corrections mean for collision risk. SpaceX's data shows 23 corrections over 6 weeks, each reducing closest approach distance. Independent university observatories have confirmed at least 18 of those corrections, with others potentially too small to detect without SpaceX's sensor resolution. So Musk's fundamental claim that ATLAS is steering closer to Earth appears factually accurate based on observable evidence. However, trajectory prediction becomes exponentially harder when the object being tracked has propulsion and can change course. NASA's reluctance to provide definitive trajectory projections might reflect genuine uncertainty rather than deception. Predicting where Atlas will be 28 days from now requires assumptions about future maneuvers, and those assumptions might be impossible to make reliably. An orbital mechanics specialist explained the prediction challenge. With asteroids, we calculate trajectories based on gravity and momentum, predictable forces. With Atlas, we have to guess what the object will choose to do next. If it continues current maneuvering patterns, Musk's collision scenario is plausible. If it changes behavior, the whole prediction becomes invalid. NASA's caution might reflect that uncertainty. But here's what multiple tracking sources agree on. Atlas is currently on a trajectory that brings it inside lunar orbital distance, closer to Earth than the Moon. Whether it passes by safely at that distance or makes additional corrections that bring it closer or even impacts Earth depends on decisions Atlas makes that we can't predict. Musk's 12% collision probability might be defensible if we assume Atlas continues current behavior patterns. But that's a huge assumption. We're essentially betting that an object with demonstrated maneuvering capability won't make the additional course changes needed to avoid Earth, which seems like an unlikely bet if ATLAS wants to avoid collision. This creates a paradox. If ATLAS has propulsion sufficient to steer toward Earth, it logically also has propulsion sufficient to steer away from Earth. So unless collision is deliberate, an attack or test, why would Atlas position itself this close without planning to make final avoidance maneuvers? That paradox is why some scientists dismiss Musk's warnings entirely. Why would an advanced object capable of interstellar travel accidentally crash into Earth through poor navigation? It makes no logical sense. Therefore, either Atlas isn't actually on a collision course, NASA's position, or any apparent collision trajectory is deliberate and can't be predicted without understanding ATLAS's intentions, a terrifying middle ground. If Musk's warnings are accurate and ATLAS does maintain a collision trajectory, what would actually happen? The impact scenarios range from catastrophic to potentially civilization ending, depending on several factors. Atlas is estimated at approximately 800 meters in diameter based on telescopic observations. An object that size hitting Earth at cosmic velocities, even after some deceleration, would release energy equivalent to thousands of nuclear weapons. For comparison, the object that killed the dinosaurs was roughly 10 kilometers across. Atlas is smaller but still large enough to cause devastation on continental scales. A planetary defense researcher calculated the impact effects. An 800-meter object impacting at 20 to 30 kilometers per second would create a crater 15 to 20 kilometers wide. The immediate blast would devastate everything within 200 to 300 kilometer radius. Shockwaves, fires, and debris ejection would extend effects globally. It wouldn't be extinction level, but it would kill millions directly and potentially billions through subsequent climate effects. But those calculations assume Atlas is a solid rocky object. We don't actually know what ATLAS is made of. If it's metallic, impacts would be even more destructive. If it's hollow or contains mostly low-density material, impacts might be less catastrophic. Our complete uncertainty about ATLAS's composition means impact predictions have enormous error bars. There's also the possibility that ATLAS doesn't actually impact Earth, but breaks apart in the atmosphere, creating multiple smaller impacts spread across a region rather than one massive crater. This happened with the Chelyabinsk meteor, a much smaller object that fragmented in atmosphere, spreading damage across a wide area but avoiding concentrated catastrophic impact. However, Musk himself posted about a scenario that's even more concerning than simple impact. What if collision is deliberate and Atlas has mechanisms to maximize damage? An object with propulsion and guidance could theoretically steer itself toward high population areas rather than randomly hitting wherever trajectory dictates. Musk wrote, "If Atlas has intelligence and hostile intent, we're not just facing an asteroid impact, we're facing a precisely targeted kinetic weapon." The difference between random impact in ocean or desert versus targeted impact on New York or Shanghai is hundreds of millions of lives. Military analysts have considered this possibility and find it deeply troubling. A guided impactor would essentially be an unstoppable weapon, traveling too fast to intercept, too large to destroy, and capable of steering to evade defensive attempts. If Atlas represents deliberate weaponization, we have no meaningful defense. But there's another possibility that Musk mentioned and then didn't elaborate on. What if Atlas doesn't plan to impact at all, but plans to stop? An object with the propulsion capability to change course 23 times could theoretically decelerate enough to insert into Earth orbit rather than collide with the planet. That scenario would be first contact, not impact, and potentially more significant than collision. Musk has used the ATLAS situation to reinforce his long-standing argument that humanity needs to become multiplanetary. And his reasoning is compelling even if you question his collision predictions. In several posts and interviews following his Atlas warnings, Musk emphasized that Earth faces numerous existential risks: asteroid impacts, nuclear war, climate catastrophe, pandemic disease, artificial intelligence gone wrong. His argument: any single planet species is vulnerable to extinction from any one of these threats. Spreading to multiple worlds ensures survival. Musk stated bluntly, "Atlas, whether it hits us or not, proves we're sitting ducks on one planet. A sufficiently advanced threat could wipe us out and we'd have no backup. Mars colony means even if Earth is destroyed, human consciousness survives. That's worth any price." Critics argue Musk is opportunistically using Atlas fears to promote his business interests. SpaceX's entire Mars program depends on convincing people that planetary backup is necessary and urgent. Overstating Atlas collision risks serves that agenda by making existential threats feel immediate rather than hypothetical. A space policy critic described the conflict of interest. Musk runs a company that profits from Mars missions. He has every incentive to make space threats seem more serious than they are. His Atlas warnings, whether accurate or not, serve his business model by increasing urgency around Mars colonization. We should consider his financial motivations when evaluating his scientific claims. But other analysts point out that Musk has been warning about existential risks and arguing for Mars colonization for decades, long before ATLAS appeared. His consistency suggests genuine belief rather than opportunistic fear-mongering. He might be leveraging ATLAS to advance pre-existing arguments, but that doesn't necessarily make those arguments wrong. A Mars colonization advocate explained, "Even if Musk's wrong about Atlas collision probability, he's right about the broader point. Humanity concentrated on one planet is vulnerable to numerous threats. Atlas is just the current example of how quickly a space-based threat could emerge. The argument for planetary redundancy doesn't depend on ATLAS specifically." Musk has also proposed that SpaceX could use Starship to evacuate key personnel and genetic material to Mars if ATLAS impact becomes certain. While this sounds like science fiction, the technical capability might actually exist. Starship is designed to carry 100+ passengers to Mars. If given weeks of warning before impact, multiple launches could move thousands of people and vast quantities of supplies off-world. This raises uncomfortable ethical questions. Who decides who gets evacuated? Who has the right to make that choice? In a scenario where only thousands can be saved from billions, the selection process becomes a moral nightmare that reveals difficult truths about how we value different lives. As Musk's 28-day collision window approaches, the uncertainty about Atlas's true trajectory and intentions creates psychological stress for anyone paying attention. Every day without clearer information is another day of not knowing whether to prepare for impact or dismiss the warnings. Musk continues posting updates as SpaceX tracks Atlas, and the updates are mixed. Some days he reports that ATLAS made additional course corrections, reinforcing collision concerns. Other days he notes that trajectory remains stable with no new maneuvers, which could suggest Atlas has reached its intended position and won't close further distance. The businessman has been remarkably transparent about uncertainty. "We're tracking this as well as we can, but we're guessing about intentions. Atlas could veer away tomorrow. It could crash into us in 28 days. It could park in orbit and start talking to us. I don't know. Nobody knows. What I do know is that we should be preparing for the worst-case scenario while hoping for better outcomes." NASA has slightly modified their messaging over time, moving from complete dismissal of collision risks to statements like, "We continue to monitor closely and will provide updates if threat assessment changes." That shift is subtle but significant. It acknowledges that threat level isn't zero, even if NASA still considers impact unlikely. Independent astronomers tracking ATLAS have formed a global network sharing observations constantly. They're documenting every maneuver, every energy emission, every change in ATLAS's behavior. This distributed tracking network means we'll likely have some warning if ATLAS makes the critical trajectory changes that would confirm collision course. But some warning might only be days or even hours. If Atlas can execute course corrections as quickly as observed, it could shift from safe flyby to collision course faster than we can mount defensive response. The time between knowing impact is certain and impact actually occurring might be too short for meaningful evacuation or protection. Musk has urged governments to activate emergency protocols regardless of uncertainty. Better to evacuate coastal cities and critical infrastructure unnecessarily than fail to act and watch millions die because we didn't want to cause panic. Yes, evacuation costs money and disrupts lives, but weigh that against even a small probability of mass casualties. Some local governments, particularly in regions that would face tsunami risks from ocean impact, have quietly begun updating evacuation plans and positioning emergency resources. These preparations haven't been publicly announced to avoid panic, but the movement of supplies and pre-positioning of response teams is visible to observers paying attention. So what's the reality? Is Musk right to warn about collision, or is this alarmism serving his business interests? The truth appears to be somewhere uncomfortable in the middle. Atlas is definitely steering closer to Earth. That's observable fact confirmed by multiple tracking sources. Whether those course corrections represent intentional targeting of Earth, preparation for close flyby, or navigation towards some other destination with Earth approach as a side effect, we genuinely don't know. Musk's 12% collision probability might be defensible given observed behavior patterns, but it requires assumptions about Atlas continuing current trajectory trends without making final avoidance maneuvers. Those assumptions could be completely wrong if ATLAS plans to veer away at the last moment. NASA's caution about not wanting to cause premature panic is understandable, but their lack of transparency about their own trajectory models and assessment criteria undermines public trust. If they have data suggesting Musk is wrong, they should share it. If they don't have better data, they should admit uncertainty rather than projecting false confidence. The most likely scenario, based on available information, is that ATLAS will pass extremely close to Earth, closer than the Moon, possibly within tens of thousands of miles, but will not actually impact. Objects with Atlas's demonstrated capabilities don't navigate across interstellar distances and then accidentally crash into planets through poor path planning. However, most likely is not the same as certain. There remains a non-zero probability that ATLAS's close approach could result in impact, either through miscalculation, deliberate choice, or some failure of whatever guidance systems control it. In 28 days, we'll know whether Musk's warnings were justified caution or unnecessary alarmism. We'll know whether ATLAS passes safely, impacts Earth, or does something none of us predicted. What we know right now is that an object from another star system is steering itself uncomfortably close to our planet, and we don't know why. Whether that's cause for panic or just fascinating science is something each person must decide for themselves. What do you think? Is Musk right to warn about collision risk, or is he overstating dangers to promote Mars colonization? Should we be evacuating coastal cities, or is that premature panic? Drop your thoughts in the comments and subscribe, because in 28 days when that collision window arrives, you'll want to know immediately what happens.